Next geometrical construction is bisection of an angle. It may be acute angle, it may be right angle, or it may be obtuse angle. So, the common method for that, bisection of angle bisection method. Okay, we have learned perpendicular bisection of a straight line. Now, three different kinds of angles everybody knows. Which are those? Suppose this is A, that is acute angle. B, right angle. And C, third one is obtuse angle. So construction method is same, though it may be acute, though it may be right, or though it may be obtuse angle. What is the procedure? First of all, draw two straight lines carrying one acute angle, any angle acute angle. Okay, in this way. Now, what is the procedure for bisection? Angle bisection. Okay, just observe here. Suppose this angle is, I will name it as A, B, and C. I have to bisect this angle. What is the procedure? As usual, pick the best friend, that is compass. Pick any convenient radius in compass, mark two arcs. First, put the needle over B, get first arc on AB with the same radius on BC. Okay, suppose these points are P and Q. Now we can change the distance between the legs of the compass and get two intersecting arcs. First from P as a center. Interchange the position of the needle, place it here with Q, get intersecting arc. So this intersecting point of both these arcs, when we will connect with this P, it is going to yield us the angle bisection, that is the desired or expected solution. Both the angles will be of same degree. You can check it by using protractor. Okay, so this is the acute angle bisection method. Same is the trick for right angle also. Okay, first of all, what you have to do, just for the sake of practice of first construction method, we will construct right angle geometrically without using protractor. So what is the first procedure? Suppose this is a horizontal line AB. What is the first construction method? To draw a perpendicular line through the extremities of the given line. So through A only we have to construct one perpendicular line. What is the procedure? Pick any convenient radius in compass, A as a center, draw one long arc in this way. With the same radius, mark two consecutive arcs over the earlier drawn arc. Now you are free to change the radius. Now suppose this point is M and this one is M. Again pick the convenient radius distance in compass and first arc you have to get M as a center above the space, above this curvature. Okay, with the same radius without changing the distance, get intersecting arc. You have got that point of intersection of both these arcs here. Now we will connect this point, intersecting point with A. You are going to get the right angle line to this AB. Suppose this is C, AC. CAB is the right angle. Now what is the next procedure? By this you have got this right angle now. We are going to bisect this right angle. Same trick you have to implement there. Pick any convenient distance, convenient radius in compass and get two arcs from A only. From B we have marked in this way, Q and P, equidistant from B. Similarly, with the same distance from A, get first arc here, second arc here. Okay, now intersecting arcs from both these points. First of all, highlight, make them bold points, and now You can change the distance and get to intersecting arcs in the space in this way with the same radius without disturbing the distance between both the legs. Okay. Now that intersecting arc, you have to, that point you have to connect with A and you have to extend it up. So naturally this angle and this angle both will be carrying same 45-degree angle. You can check it by using protractor. Same way, obtuse angle, any obtuse angle, any, it may be 60, it may be 100, 120, any acute angle. First of all, you construct here any acute angle. No need to measure by using protractor. Still, by the same trick, we are going to get its bisection. Okay. Same trick. Mark two arcs of same radius and intersecting arcs from earlier drawn arcs. In this way, you are getting space. This intersecting point connected to this corner. So we are going to get these two equal angles, so that angle bisection of obtuse angle also we have learned. Okay, this is the actual trick for bisecting any kind of angle. Same unique method. That too, it is giving us the precise angle bisection. Okay. Now next, we start with the construction of triangles. All the different three kinds of triangles are there. Which are those? First one is equilateral triangle, second one is isosceles triangle, and third one is scalar one. Okay. After that, square, four-sided figures are square, rhombus, parallelogram is there, and rectangle is there, and all the gon family, that is polygons, polygonal family. Which are those? So starting with the pentagon, hexagon, heptagon, octagon, nanogon, likewise. Okay. So we'll start first of all with simple three-sided figure, which is called as triangle. Okay. So first, equilateral triangle. Equilateral triangle. We are going to construct an equilateral triangle possessing 50 mm side length. So what is the procedure? You have learned this equilateral triangle in, I think, in 5th or 6th standard. The same procedure we are going to repeat here. Nothing is new. Okay. Very simple construction. Horizontal line. This equilateral triangle or triangular family is required in case of creation of planes, creation of solids, section of solids, and development of lateral surfaces likewise. So it is very essential to construct regular figures. Okay. So equilateral triangle is nothing but the regular triangle, we can say. So first of all, I have drawn AB as the 50 mm long segment with the same distance of 50 mm. Pick the same distance from the line itself. Don't use scale, not at all. Okay, it's not required. Now A as a center with this 50 mm as its radius, get one arc above this line in the space in this way, long arc. Now interchange the position of the needle. Now instead of A, now the same needle you have to place over B to get intersecting arc to earlier drawn arc. So this point of intersection of both these arcs is nothing but C. When you connect with A and B, naturally you are going to get three equal sided figure, which is nothing but it is called as equilateral triangle. All the three sides are of same length. So naturally all the three angles are of 60 degrees. Okay, this is all about equilateral triangle. The second, isosceles triangle. ISOSCE, isosceles triangle. To draw an isosceles triangle, consider It is given as base as 40 mm and it is carrying height of 80 mm. So we are going to construct one isosceles triangle carrying base 40 mm and it is carrying or it is possessing height of 80 mm. What is the procedure? Instead of the side length of equal sides, what is given here? Height is given, base and height. So naturally we should start with its base. So base, suppose this is 40 mm base, extrements mn, I give name mn. Mn is the base of 40 mm. What is the procedure? Next procedure, height you have to mark here, 8 mm. How to mark the height? First of all, we should construct bisector, perpendicular bisector, or a line perpendicular to this mn, that too at its midpoint. So naturally, best trick is to construct perpendicular bisector. We have learned that construction last time. So more than half of the distance in compass you have to pick, and intersecting arcs above and below the line by interchanging the position of the needle. First from M, second from N. Get intersecting arcs, and in this way both the intersecting points we have got here, that you have to connect and extend it up over. Okay, so height is 80 mm. From this point only you have to mark height, that too in upward direction. Okay, so this is 40, this much I have taken as 40. So twice I have to mark here, so that naturally I am going to get point Mn. Suppose this is Q. Okay, this Q when you join with M, we are going to get M and N, isosceles triangle carrying 40 mm base and 80 mm as its height. These two sides naturally both are carrying same length, equal length, identical. That's why such kind of triangle is said to be an isosceles triangle. Okay. Scale and triangle is nothing but right angle triangle, or we can say set square, which is kept in the 30, 60, 90 set square in your compass. It is nothing but the scalar. All the three sides are of different length, and all the corners are also carrying different inclination, 30, 60 and 90. That triangle, that set square is said to be, is termed as scalar. Okay. Now we construct square. Square is also required frequently for projection of planes, projection of solids, section of solids, and development of laterals. All the four topics, this square size, it is also important, equally important, just like triangle. Okay, so square, very simple method of construction of square. Draw one horizontal line. Suppose we are going to construct a square carrying 35 mm side length. So first of all, you construct a horizontal line carrying 35 mm side. Okay. Now geometrically we are going to construct this square. So naturally we should repeat the first construction method, whatever we have learned, that is to construct, to draw perpendicular to a given line through both of its extremities, that we have learned earlier. The same procedure we have to repeat here, and I am going to mark both the arcs of same radius in this way. Same radius. With the same radius, two consecutive arcs on the earlier drawn arc. There should not be any variation in the radius. I have kept both the, all the four radius, 1, 2, 3 and 4. 4 radii of the same radius. Same radius. Okay. Now you can change the radius and get intersecting arcs in this way by interchanging the position of the needle. First from here, second from here. Similarly, with the same radius, or you can vary the radius also. But while taking the intersecting arcs, both the radius should be of same length. The dimension should be same. There should not be any variation. Otherwise, you will be in trouble. Now this intersecting point you connect with A and extend it. Similarly, extend it. Now simply what you have to do, this length of 35 mm we can compass from A and from B. Same distance you have to mark over. It's very simple. So this point will be C, this point will be D. Connect it with fair lines, continuous thick lines. First kind of line is continuous thick line. Okay, this is nothing but square carrying 35 mm side line. Same rectangle also you can construct. It's very simple construction for rectangle. It's very easy. No need to show, but it is essential while learning the projection of planes. That's why we'll just say one simple rectangle we will construct, that is carrying 40 mm width or breadth and 70 mm length. Okay. So rectangle. It's very simple construction. Very fast we will see it. For that again same procedure, just like square. First of all, you have to construct length here. Suppose this is AB length 70 mm. AB is of 70 mm length, and geometrically we are going to construct. So no need to tell. Once again, it is nothing but the revision of first geometrical construction method of constructing perpendicular line. Okay, the same procedure I am going to repeat. It's very simple. Just now we are drawn square. The same procedure I am going to repeat here. So nothing is novel, nothing is new here. It's very simple trick. Intersecting arc we should get here. Ultimately, this angle should be 90 mm. That you should take care of your entire construction. Okay. After that, just you have to mark its breadth above A and above B on these construction lines. How much it is? 40 mm. Yes. From A 40, from B also 40. I will mark, and simply you have to connect these points so that naturally A, B, C and D. This is the desired solution of rectangle A, B, C, D. These two are lengths, these two are width or breadths of the rectangle. Okay. This is required to be constructed in any manner, in this way or vertically, likewise, depending on the direction of the projection of planes. This is all about construction of triangle, square and rectangle. Now we are entering into the polygon figures, polygonal views, polygonal figures.